I want to construct an isosceles triangle, then I'm going to create it similar that I do when I'm making an equilateral triangle. The only difference is I don't have to make sure that my equilateral on my isosceles, I don't have to make sure that I stretch my compass all the way from A to B. If I was doing equilateral, I would stretch my compass all the way from A to B. That's not really what I have to do. If I want to make isosceles, then I don't need my segment to be the same length as AB. I need the segment that comes from A to be the same length that comes from B. So I'm going to create an arbitrary length. I just made sure that it went more than halfway past my segment. I'm eyeballing that the midpoint of my segment is right about here where my cursor is, so I stretched my compass to a little more than halfway. I'm going to do an arc mark at the top, and I'm going to do an arc mark at the bottom. So I really just drew half a circle there. Now I'm going to keep my compass the same width and move my endpoint to B. And I'm going to mark where my compass crosses this arc, the other arc that I had already made. It crosses at 2 intersection points. And if I'll join them, then we know that this line that I just drew is the perpendicular bisector of segment AB. What we may not have learned is that any point that's on that segment would represent a point that would be a vertex in an isosceles triangle. So let's say that I pick a random point on that segment, and I join that random point to A, and then join that same random point. It's not really random, it's the point that's on the perpendicular bisector. That same point to B. I will have created an isosceles triangle. And my sides should be same length, which I can verify. Stretch my compass. I didn't do very good with my vertex. I should have been a little more exact with my ruler. But see how long that segment is? And this segment over here matches that segment length. So I know that I have created an isosceles triangle. So we can name this vertex point up top C. And I have myself an isosceles triangle. Now, remember, any point along that perpendicular bisector would work to make me an isosceles triangle.